सो हेलो नमस्कार टू द ऑल केमिस्ट्री लवर्स डॉक्टर्स एंड इंजीनियर्स ऑफ द नियर फ्यूचर। मैं विजय कुमार सोनी आपका हार्दिक स्वागत करता हूं केमिस्ट्री वाला चैनल रिगार्डिंग टू योर वन एंड ओनली केमिस्ट्री। In previous video we have discussed about just important topic that is called Gauss law. Now the time we discuss about the another important topic that is very important and called as just electrolysis. So what is the mean of electrolysis and process of electrolysis? So this is the electrolysis. As we all know, just whenever it will be flow of current through the electrolyte, then it dissociates into their constituted ion, and this process is called as just electrolysis. So you will say just dissociation of dissociation of a substance into their constituted ion, just dissociation of a substance into their constituted ions during flow of current in molten and solution state. Solution state called as electrolysis. Electrolysis. Those substances are known as electrolytes. Substances are known as called as electrolytes. If we go with this process, then this process take place in electrolytic cell. इलेक्ट्रोलिटिक सेल जिनके बारे में हम लोग डिस्कस कर चुके हैं. एन इलेक्ट्रोलिटिक सेल कैथोड विल बी नेगेटिव टर्मिनल while anode will be as a positive terminal. This is the positive terminal, but here negative terminal is called as cathode, and here this is called as anode, as we have discussed cathode and anode. This was about the just two important electrodes. If we'll go with the just diagrammatically, then in external circuit, in external, the electrolytic cell looks like as follows. These are the two electrodes. Here will the electrolyte which is to be used. So this is the electrolyte. The negative terminal is called as cathode, towards which cation moves, and this is the anode, towards which anion moves. This was about the structure of electrolytic cell. Electrolytic cell. Now the time to discuss about the just further. If we'll go with the just electrolysis, then during electrolysis it will formation of just you can say cation and anion. If we go with just cation and anion, then cation moves towards cathode and anion moves towards anode. This is perfect for the just electrolytic cell. Here are some of the important examples जो कि बोर्ड के रिगार्डिंग काफी इंपॉर्टेंट है. First example is your electrolysis of molten NaCl. NaCl आपके पास में सॉलिड था, उसको फ्यूज कर लिया, लिक्विड स्टेट में चेंज कर लिया, मेल्ट कर लिया और उसका आपने इलेक्ट्रोलाइसिस करवाया. Then it will be use of this electrolytic cell. Here will be molten or fused NaCl. So we can use another word also. This is also called as fused NaCl. First of all, it will go with the reaction. Then reaction is as follows: 2 of NaCl. Here will dissociation in 2 of Na plus and 2 of Cl minus. This is the cation, this is the anion. Here are the two terminals as a cathode, negative terminal, and as a anode, that will be your positive terminal. Cathode means towards which cation moves. Cation is your 2 of Na plus. So this is the 2 of Na plus. Here it will be gain of 2 electron and it reduces in 2 of Na. So we can say here will process of reduction reaction, and if we'll go with the just anode, then here 2 of Cl minus changes in Cl2 with the loss of 2 electron. Loss of electron is called as oxidation reaction. If we'll go with the just net cell reaction, then from 2 electron to 2 electron remains cancelled, left and right side. Here will just 2 of Na plus and 2 of Cl minus. It is your just 2 of Na, just a solid form. It will be deposition of the sodium metal, and here will release of the dichlorine gas. So what we can say that by electrolysis of fused or molten NaCl, it will formation of sodium metal. Sodium metal will form over the cathode. Sodium metal will form over the cathode, and if we go with the just anode, then it will formation of the dichlorine gas. Dichlorine gas over the just your anode. This is the dichlorine gas over the anode. So this was about the just first example regarding to just electrolysis, the meaning of electrolysis and how they will shift and what will be formation of the substance or different electrodes. This is very important. It's a very important part because of there are 5 examples regarding to electrolysis. So you have to go through with the each and every example. Now the time to discuss about the important example, another important example, that is the, we can say just electrolysis of aqueous solution of NaCl. It's very important. Go through with the each and every example properly because of it will be one of the example in the board exam. So an entire Faraday law is also based on electrolysis, so you have to go through with this. Second example is your electrolysis of aqueous solution of NaCl. Now this time we'll take just aqueous solution and it will use of same with the electrolytic cell, that is also called as Kastner-Kellner cell, or over here Kastner-Kellner cell, and here will also use of Kastner-Kellner cell. The structure which we have just explained in the first slide will be same. Process is your, this is the 2 of NaCl through the electrolysis. Here is the water aqueous solution. This is your again electrolysis. This is the electrolysis. It changes in 2 of Na plus and 2 of Cl minus. If we'll go with the further, then it will change in 2 of H plus and 2 of OH minus. Now the time to discuss about the just movement of the cation and anion. If we'll go with the just cathode, then towards which cation moves. Here cation is Na plus and just H plus, both are cation. But remember one thing, deposition electrode potential for the hydrogen is less than the sodium. So it will be movement of 2 of H plus ion and it will be release of S2 gas by the gain of electron. Here's the just gain of electron similar, so it will be reduction reaction. If we will go with the another, then that is the anode as a positive terminal. This is your here once again the deposition electrode potential for the chloride will be less, so it will be movement and it changes in Cl2 gas with the release of 2 electron. Here is the loss of electron, so it is called as oxidation reaction. The Naxal reaction, if we'll go with the Naxal reaction, then these two electron remains cancelled. Here will formation of just S2 gas and Cl2 gas over the different electrodes. डिफरेंट इलेक्ट्रोड पे कैथोड से S2 गैस और एनोड से Cl2 गैस रिलीज होगी एंड रेस्ट इन मीडियम मीडियम में क्या होगा रिमेनिंग इज योर Na plus and OH minus both combines with each other Na plus and 2 of OH minus to give just 2 of NaOH. So we'll say the entire nature of the entire solution will be basic. So the solution will be basic solution, and this is also called as industrial. This is also called as industrial preparation method. Preparation method of NaOH. Just you can say sodium hydroxide, or you can say just caustic soda. So this was about the preparation method of NaOH, and this was about the just electrolysis of NaCl. See the entire metal go through properly. We'll go with the just third important example, that is your acid diluted water. So now the time to discuss about the third electrolysis. What is that? That is the electrolysis of acid diluted water. There are 5 important examples, and for both of these it will be use of platinum electrode. So don't be confused. This is the second example. Now we'll go with the third example. This is the third example as a electrolysis of acid diluted water. So here will use of water. Here is the electrolysis. Change in 2 of H plus and 2 of OH minus. Here will use as a H2SO4 as an acid. It also dissociates in 2 of H plus and SO4 2 minus. Here will use of platinum electrode, PT electrode, inert electrode for this. First of all, this is the cathode. Over the cathode, which is negative electrode, here will movement of cation. As a cation you can take just 2 of H from here, 2 of H from here. So total is your, according to stoichiometric, 4 of H plus. Whenever they gains electron, then it will change in just 2 of H2. Here's the gain of electron, that's why it is called as reduction reaction. Now I would like to go with the just anode. Anode is your positive terminal. From anode it will be just 2 of OH minus, but for the stoichiometry we will use just 4 of OH minus. First of all, it loses just 4 electrons, so changes in 4 of OH, and rest it will be 4 electron. This is the loss of electron called as oxidation reaction. In the step 4 of OH combines with each other to give the 2 of H2O plus O2. Now reaction is balanced for oxygen and for hydrogen. This is the second part. Overall reaction will be, this is the overall reaction. These 4 electron to 4 electron, here is the 4 electron remains cancelled, and 4 of OH and 4 of OH, this will be your 4 of H plus, 4 of OH minus, and next is your 2 of H2, release of H2 gas, just formation of the 2 of H2O plus release of O2 gas. So this is also preparation method of dihydrogen and dioxygen also, regarding to, you can say, just industrial method of H2 and O2. If we'll go with a further, rest in medium, there will SO4 2 minus ions. This was about the just electrolysis of acid diluted water. Now the time to discuss about the fourth important example, just you can say electrolysis of aqueous solution of you can say CuSO4. But remember one thing, here will using platinum electrode का यूज करना है. Same it will use of just once again electrolytic cell. So we can say the reaction is your CuSO4. Here dissociation by electrolysis will be in Cu plus 2 and your SO4 2 minus. Here just according to stoichiometric we can take just 2, so here will 2 and 2. Water also, so what will be here, we can use just your 2 of H2O like this. It also dissociates in 2 of H plus and just 2 of OH minus. If we'll go with the further, then this is the cathode towards which cation moves, means negative electrode. As a cation, here will movement of just 2 of Cu plus 2 because they exist less value of deposition electrode potential. You have to learn. So these are the 2 of Cu plus 2 gains 4 of electron and changes in, you can say, just 2 of Cu. So here will formation of copper metal or deposition over the cathode, and over the anode, this is the anode, this is the positive terminal, and as we know that here is just 2 of H2O. So regarding to it, we can take just your 4 of H2O, 2 of H2O, it will be just 2 of H plus and 2 of OH minus, and according to stoichiometry, here is the 4 electrons, so we'll take just 4 of H plus and 4 of OH minus. This is the 4 of OH minus. So between just SO4 2 minus and OH minus, it will be less value of the deposition electrode potential for just OH minus. So what will be the movement of 4 of OH minus with the loss of 4 electron? Here will formation of 4 OH plus 4 of electron. This is the gain of electron, that's why it is called as reduction reaction. And here is the loss of electron, that's why it is called as oxidation reaction. This is the most important, कहेंगे आप इसको oxidation reaction. Overall reaction निकालें, then what will be? From these 4 electron to 4 electron remains cancelled. Here will 2 of Cu plus 2, just 4 of OH minus. We can say one thing is also, what is that? Listen me carefully. These 4 of OH minus, 4 of OH changes in 2 of H2O and plus O2. Now the net cell reaction, net reaction, or you can say overall reaction, net reaction or overall reaction. These four OH, 4OH remains cancelled. Rest left or right के part को arrange कर दीजिए. This is the 2 of Cu plus 2. This is the 4 of OH minus. Changes in just 2 of Cu and just it will formation of 2 of H2O and release of O2 gas take place. If we'll go with the balancing, then 2 of Cu. This is the 2 of Cu. Arrow is downward. Here is the 4 of hydrogen and 4 of oxygen. Rest in medium. Rest in medium. What will be? There are just 4 of H plus and 2 of SO4 2 minus, because we have taken just copper ion and hydroxyl ion. So rest in medium, it will be 4 of H plus. This is the 2 of SO4 2 minus, combines with each other to give just 2 of H2SO4, and H2SO4 is known as sulfuric acid. Sulfuric acid, it acts as a strong acid, so the nature of medium will be acidic. So we can say medium will be acidic. This was about the just fourth electrolysis of aqueous solution of CuSO4 by using just a platinum electrode. Being game, it's too important because of it will be one of the electrolysis in your theory, and without learning this you can't do just Faraday law. So read the matter properly. And start to your journey, because of I have uploaded a lot of chapter, so please. Now the time to discuss about the fifth important example. We can say that is the electrolysis of aqueous solution of CuSO4, but by using copper electrode. None another kind of the, just you can say platinum electrode. Here will use of your copper electrode. So being game. So this is the fourth part, that is the electrolysis of aqueous CuSO4, but here will use of by using Cu electrode, copper electrode. So what will be just CuSO4 के regarding बात करें, so it dissociate in Cu plus 2. This is the electrolysis. Here will formation of Cu plus 2 and 2 just SO4 2 minus. Here is the water molecule. So again here will formation of 2 of H plus and 2 of OH minus. As a cathode, negative terminal, here is the cation as a Cu plus 2, which adjusts less value of the deposition in electron potential. So these gains electron and changes in 2 of Cu. This is the Cu, and this is called as reaction. Anode as a positive terminal. Here will not movement of neither SO4 2 minus nor OH minus ion, दोनों का ही मूवमेंट नहीं होगा. इन दैट केस पर्टिकुलर खुद कॉपर का जो इलेक्ट्रोड है वो अपने आप को ऑक्सीडाइज करेगा, लाइक दिस Cu plus 2 and just 2 of electron. This is called as oxidation reaction. The net cell reaction or overall reaction, what will be? from 2 electron to 2 electron remains cancelled, from Cu plus 2 to Cu plus 2 remains cancelled, and just here will disappearing of the anode copper as an electrode, कॉपर इलेक्ट्रोड का डिसअपियरिंग होगा और टोटल रिएक्शन न्यूट्रल होगी. सो मीडियम will neither acidic nor basic. If anybody asks you what is the actual mean of electrolysis, electrolysis का mean क्या है, कहाँ यूज होता है, then you will say this is the note. Electrolysis is applicable in extraction of metals, and in electroplating. किसी भी मेटल पे किसी दूसरी इलेक्ट्रोप्लेटिंग, दूसरी मेटल की लेयर चलानी हो तो पर्टिकुलर इलेक्ट्रोलाइसिस प्रोसेस का यूज करते हैं. सो दिस वाज एंटायर पार्ट ऑफ द इलेक्ट्रोलाइसिस. सो डियर डॉक्टर्स एंड इंजीनियर्स, पर्टिकुलर इसी विश्वास के साथ में आपसे फिर मुलाकात होगी एक नए टॉपिक के साथ में, जिसको हम पर्टिकुलर फैराडे लॉ कहते हैं. फैराडे लॉ क्या है, इसके फेवर में दो लॉज हैं फैराडे के फेवर में. डिफरेंट आपने पर्टिकुलर इलेक्ट्रोलाइसिस जो पढ़े हैं कि कैथोड पे कितना अमाउंट बना, एनोड पे कितना बना, उस अमाउंट को कितना करंट फ्लो किया उसके साथ में कोरिलेट करके फैराडे ने दो लॉज प्रपोज किए. इसी तरीके से अपना विश्वास मुझे जताते रहिए. नो डाउट एक दिन सक्सेस जरूर मिलेगी. व्हाइट अप्रिंट जरूर पहनेंगे और एक अच्छे ऑफिस में बैठ करके इंजीनियर की हैसियत से जरूर ज्वाइन करेंगे, इसी विश्वास के साथ में कि आपका सपोर्ट, आपका प्यार यही मिलता रहेगा. तब तक के लिए शुक्रिया, धन्यवाद. आपसे फिर मुलाकात होगी अगले वीडियो में. धन्यवाद वंस अगेन.